In question one, in section 1.2, we're gonna start talking about variables and expressions and equations. A variable to begin, well, let me write something like 3x, for example. The variable is represented with a letter usually, and most of the time we use x or y, but it could be any letter, which is then we call it variable because it can vary. I can come and say, well, for right now, the x value is 3. The, the next question, I can come and say that x value is 5 or 7 or whatever I want. So x can vary, so that's why we call it variable. Number that is by itself, like for example, 5, let me write this as 3x plus 5. The 5 is what we call a constant because no matter what value I give it to x, 5 keeps on being just 5, right? It's constant. The number with the variable, we're not going to see it much today, but the number with a variable, we call that coefficient. So the 3 is a coefficient, the x is the variable, and the 5 is what we call the constant. Now, on algebraic expression, what we mean with an algebraic expression is basically operations put together. Like I can come and say 3x plus 5 minus 2y, or plus this times that, divided by that, or we can use that basically operations as what we call an algebraic expression. But if we include, so all that's an expression. But if we include an equal sign, and let's say I came over and said 3x plus 5 minus 2y equals 42. Once I include an equal sign, I'm going to call that an equation. So we're going to talk a little bit more later on in this section, but just in a nutshell, that's basically what it is. As soon as I include an equal sign, it's an equation. No equal sign is just an expression. So as a matter of fact, the left of the equal sign, that's an expression. The right of the equal sign, that's also an expression, even though it's just one number. So that's basically what it is. For today, we're going to start with evaluating each expression for x equals 5. So what we're told is this is an expression. As we can see, there are no equal signs. But what we're told is x is equal to 5. So for example A, I'm looking at a plus 5, which I'm going to evaluate it. Evaluate means work it all the way through. A plus 5, I'm going to call that 13. For example B, when two numbers are put together, 8 and x, I'm going to use a parentheses because I don't want it to look like 85. So when two numbers are put together, 8 and 5, that means times. 8 times 5 is 40. Now here, I'm going to go 2 times 5 minus 9. Once again, I use parentheses for the x for 5 just because I don't want it to look, in this case, 25. I want it to look like 2 times 5. So I know I multiply first, so 10 minus 9 is equal to 1. Now here I have 3, and then I have 5 squared. From our order operations, which is in the previous section, we learned that I have to do exponents before I multiplied. So let me do 5 squared first. I know 5 to the second power. In my mind, I'm thinking 5 times 5. So that is 25. So 3 times 25, I'm going to simplify that as 75. Here on the homework, you're also going to see something like evaluating each expression for x equals 5 and y equals 3. So we're going to go into two variables. So instead of x, I'm going to write 5. So 2 times 5 plus 5 times 3. But remember, for every x, replace it with 5. Every y, replace it with 3. So I have to multiply here. 2 times 5, that's 10. 5 times 3 is 15. Notice I didn't do anything with the addition. I just copied it because remember, order operations, we add at last. 10 plus 15, I'm going to call that 25. Here on the top, I have 9 times 5. Well, actually, let me write it at the bottom. I have 9 times 5 minus 8 times 3 over 2 times 5 minus 3. So just looking on the top, I have 45 minus 24, right? Because I did my multiplications there and there. I didn't do anything with the minus yet. At the bottom, I have 10 minus 3. right? I just did the 2 times 5 there. So now just looking on the top, 45 minus 24, that's 21. At the bottom, 10 minus 3, that's 7. I know a fraction is division, so 21 divided by 7, my answer should be 3. Looking at example C, I have this as 5 squared minus 2 times 3 squared. So let me do the exponents first. I have 25 minus 2 times 9. I see a minus, but I also see times. And based on order operations, I have to multiply first. So I'm going to multiply 2 times 9. So let me rewrite this as 25 minus 18. Right, all I did was multiply 2 times 9. So 25 minus 18, I'm going to call that 7. Let me clear this up. Now we're going to write each word or phrase as an algebraic expression, but not too much. Write each word or phrase as an algebraic expression using x as the variable. I have some colors in there so you guys can see that I'm separating certain things. But the first thing we have to do the sum. I know sum means I'm adding, so I'm going to add, and I'm going to do the sum of a numbered and 9. So it seems like I'm going to be adding a number and 9. So but remember, instead of number, we're going to write x because we said we're going to use x as the variable. Make sure you do write them in the order they are appearing. The numbered, or in this case x, came first, so I'm going to go x plus 9. My second example says 7. I'm just going to write my number 7 minus a number. I'm going to write each word phrase as an algebraic expression. So it's just basically write it in symbols. Then a numbered, I'm going to write a numbered subtracted from 12, but subtracted from, uh, when every time minus it comes with a from, subtracted from, I'm going to do a minus, but instead of putting it after x, I have to put it before x. So from, later on when we deal with addition, we're going to use 2, so added 2, but in this case subtracted from, it's a minus, but the 12 is not going to come after the x, it's going to come before the x. So those are keywords, subtracted from. Next, later on in addition, we're going to say added to. And there's a couple other expressions, or other phrases we're going to use. We're going to deal with those later. Now here it says, decide whether each equation has the given numbered as a solution. Is 7 a solution of 5p plus 1 equals 36? What we're asking is, replace p with 7 and see if you get an equation that is true. So let me write this as 5 times 7 plus 1 is equal to 36. I had to multiply first, so I had to look at the 5 times 7, or order operations, 5 times 7. So I have 35 plus 1 equals to 36. And I asked myself, I think here I can see it, but 35 plus 1 is 36. So I asked myself, is 36 is equal to 36? So yes, this is a solution. Now let's take a look at my example B. Is 14 over 3 a solution of 9m minus 6 equals 32? Let me see, so I'm going to have to go 9 times 14 over 3 minus 6 equals 32. When we have a whole number and a fraction, we have two things. One thing, we have to multiply with the number on the top, and we have to divide with the number at the bottom. Which one do we do first? It doesn't really matter. So we can go 9 times 14, and then the result we divide it by 3. Or we could go 9 divided by 3, and the result we multiply it with 14. Once again, you multiply or divide whichever one you want first. So in this case, I'm going to divide because it's easier to divide. So I'm going to go 9 divided by 3, that's 3, and 3 times 14, that happens to be 42. So I have 42 minus 6 is equal to 32. See, 42 minus 6, I know that's 36. So I'm asked, is 36 equals to 32? In this case, I'm going to say, no, it's not a solution. So if you get a true statement, 36 equals 36, you get the same number on both sides, then yes, it is a solution. If you get two different numbers, like at the bottom I have 36 equals 32, then no, it's not a solution. Let me clear this up. Write each word sentence as an equation. Use x as the variable. So we're going to start reading little by little. Twice, so twice means two times the sum of a numbered and forward. So let me read this. The sum of a numbered and forward, so two times the sum of a numbered and forward. Then it finishes with the phrase is 6. So equals 6. Looking at example B. 9, so I have a 9, more than, it means plus, but because of the word then, if it was just more or plus, then it will be a plus sign after the 9. But because it's more than, it's going to put a plus before the 9. I mentioned on the previous section that inequality started with the word is more than, is less than. This one does not have the word is, so it's not an inequality. The word more means plus, so we're adding, but because of the word then, we're adding it before the 9. So I might need some space. Let me just move this a little bit right there. Okay, more than. Before the plus sign, we're going to write 5 times a number. So 5 times a number. So I'm going to call that 5 times x. And then we finish it with the phrase is 49. So equals 49. We're just asked to write it. We don't need to find the value of x. We just need to write it down. Now for my example C, 7. So I'm going to write my number 7. Less than. Once again, we see the word then. This does not start with an is, so it's not an inequality. Less means minus, but because of the word then, I'm going to put the minus before the 7. Then after that, we see the phrase 3 times a numbered. So let me write down as 3x is equal to 11. Right, the last part is equal to 11, so equal to 11. Once again, then, it's a very, very important word because it changes the order. Notice how more than made us put the plus before the 9. Less than made us put the minus before 7. So then switches the orders. Now here, decide whether each of the following is an equation or an expression. Remember, equation kind of sounds like equal at the beginning, and I mentioned at the very beginning of this lesson that equation has an equal sign, expression does not have an equal sign. So for my example B, for example, there's my equal sign, so that is an equation. My example A, I do not see an equal sign anywhere, so that is what we call expression. So that's basically what you guys will see on today's homework.